The universe, vast, immeasurable, and ancient, has always concealed mysteries far beyond human comprehension. These cosmic riddles often hinder the free exchange of knowledge essential to advancing scientific understanding. However, recent astronomical observations have revealed something truly bewildering, challenging the very foundations of modern cosmology. Using the most sophisticated space telescopes available, researchers have discovered a phenomenon that defies all known physical laws of mystery that has left scientists worldwide both amazed and unsettled. Data collected by the James Webb Space Telescope has raised serious questions about the widely accepted Big Bang Theory. The findings are so significant that they could transform our fundamental understanding of the universe's origin, structure, and future. Among the many scientists grappling with this discovery is Joel Rahn and his team, whose work has uncovered something extraordinary: the unexplained disappearance of over 900 trillion stars from the observable universe. Since becoming operational, the James Webb Space Telescope, located roughly 1.5 million kilometers from Earth, has surpassed expectations by delivering exceptionally detailed images of the distant universe. In July 2022, it began detecting radiation from galaxies so far away that their light, stretched across billions of years, had shifted into the red and ultraviolet portions of the spectrum. This light, a kind of ancient time capsule, offered a glimpse into the early universe. Yet what astronomers found was entirely unexpected. Massive regions of space where hundreds of trillions of stars had seemingly vanished. These missing stars weren't subtle or faint. They had been previously documented, their light measured, and their spectra analyzed. Now they appear to be gone without a trace. No supernova remnants, no black hole radiation, and no lingering heat signatures remain to explain their absence. The scale of this disappearance is staggering. Scientists are now scrambling for answers, though so far none have proven conclusive. Some researchers theorize that the stars may still exist, but have dramatically dimmed, perhaps due to an unknown type of cosmic dust or a previously unrecognized phase in stellar evolution that renders them nearly invisible. Others suggest these stars might have collapsed directly into black holes without exploding as supernovae, bypassing known stellar death models entirely. Yet there is a more troubling theory, one that even the most experienced cosmologists find deeply unsettling. It proposes that the universe itself may be undergoing a vast transformation, a fundamental shift in its very structure. This process might be causing objects to vanish from observable reality, not through destruction, but by slipping beyond our reach. Nearly a century ago, astronomers determined that the universe is expanding. Galaxies farther from us appear to be moving away faster. This became a cornerstone of modern cosmology. But around 20 years ago, new observations overturned even that assumption. The expansion is accelerating. Galaxies aren't just receding, they're doing so at an increasing pace, making them unreachable even if we could travel at light speed. This acceleration has profound implications. When we observe the light of a star emitted 100 years ago, we're seeing it as it was 100 light years away. But when we look at a galaxy whose light has taken 100 million years to reach us, that galaxy is now much farther than 100 million light years away due to space itself stretching in the intervening time. This phenomenon, known as redshift, is not caused by galaxies moving through space, but by space expanding between us and them, stretching the light's wavelength in the process. Thanks to James Webb's advanced capabilities, astronomers can now measure redshifts with unmatched precision. By comparing the intrinsic brightness of distant galaxies to their observed brightness and redshift, scientists are reconstructing the history of the universe's expansion. But the further out they look, the more intense the redshift becomes. In some cases, the light is so stretched that the original sources may no longer exist in a recognizable form. This cosmic stretching reveals more than distance. It exposes the underlying structure of the universe. According to current models, about 68% of the universe consists of dark energy, an enigmatic force driving its accelerated expansion. Another 27% is made up of dark matter, which doesn't emit or absorb light but influences galaxies through gravity. Ordinary matter, the atoms that make up stars, planets, and people accounts for only about 5% of the universe. The rest remains an unsolved cosmic puzzle. The disappearance of these 900 trillion stars may be linked to the increasing influence of dark energy. Beyond a certain threshold, the expansion becomes so extreme that light emitted from galaxies today will never reach us, not now, not ever. Even traveling at light speed, we'd never be able to access those distant regions. They are slipping beyond the cosmic horizon, leaving our observable universe permanently. It's as though we are stranded on a shrinking island of light, surrounded by an ever-expanding sea of darkness. Although the observable universe spans roughly 93 billion light-years, only about 6% of its galaxies remain within reach. The other 94% have already crossed that threshold, carried away by the accelerating expansion with each passing second. Between 20,000 and 60,000 stars transition from reachable to unreachable. The light they emitted before this moment is still en route to us, but any light emitted from now onward never will be. This realization is deeply sobering. The universe isn't just growing, it's drifting away from us, isolating us in a progressively smaller portion of the cosmos. From a philosophical perspective, this prompts humanity to reassess its place in the grand cosmic order. We are neither at the center of the universe nor immune to time. We inhabit a brief and precious era, one in which we can still observe and explore the deep universe. If our civilization ever intends to venture beyond the Milky Way and its nearby galactic neighbors, such as Andromeda and a few dozen satellite galaxies, we must act before these regions fade beyond reach. The implications extend far beyond astronomy. What if the stellar vanishing is the result of an evolutionary process in the universe that we do not yet understand? What if the very nature of reality is changing, reshaping time and space in real time? Or could the cause lie in the actions of highly advanced civilizations manipulating energy and unimaginable skill, perhaps cloaking entire sections of the cosmos from view? While these possibilities remain speculative, they are no longer confined to the realm of science fiction. Each new insight from the James Webb Telescope blurs the line between imagination and reality. And though we may not find definitive answers anytime soon, the mystery of the vanishing stars compels us to keep searching. The universe is moving forward, not just outward through space, but onward through time, toward a destiny we cannot yet comprehend. This expanding reality may be disheartening, but it also elevates the importance of the present. The stars visible to us today may be the last glimpses we ever have of certain parts of the universe. If we wish to understand the cosmos not as mere spectators, but as participants, we must continue to explore, to question, and to invest in the pursuit of knowledge. With every second, the universe grows darker, quieter, and more remote. Yet in the light of discovery, we find meaning. And perhaps by solving the mystery of the vanished stars, we will uncover deeper truths about our own place in the cosmic story.